All right, in today's lesson, we're going to add and subtract rational functions with common denominators. So to start us off, let's just do a flashback to middle school when you learned about fractions. And you got a problem like this, 1/5 plus 2/5. And you had to add those. And remember, when you add fractions, you have to have a common denominator. Well, these already have a common denominator of 5. So I just leave that 5. And what did I do? I take the tops and add them straight away. Like I don't have to do anything else because the denominators already match. So that would give me 3/5, and there's the end of my question. So that's what we're going to do today. Is you're going to get rationals where the denominators are already in common. So we're just going to add them together and simplify. So your directions today are just going to say simplify and then state any restrictions. Okay, this is where we're upping the game. We got to state the restrictions. Remember, we can't divide by 0, so that would be our limiting factor. So let's look at number 1 here. It's 27 over 11x minus 5 over 11x. So when we solve this, we're going to notice, first of all, our denominators are the same, so it's going to carry over as 11x. The numerator, I'm just going to bring it over, 27 minus 5, and let's clean that up. It'll be 22 over 11x. Well, hopefully you recognize that I can reduce this. 11 divides by 22, that gives me a 2 in the top, right? So what's left is 2 over x. So that's part of my answer, but then I have to do the restriction. What is it that x cannot equal? Well, if I look back at my question, look at the original, 11x. So remember, if I set this equal to 0 and divide by 11, x cannot be 0. So that is where the restriction lies. So here's my answer, 2 divided by x, or 2 over x, with the restriction where x cannot be 0. Let's try the next one. 3x over 4 plus x plus 8 over 4. And then let's see where that lands us. Notice the denominators match. So I'm going to keep my denominator as 4. And I'm going to bring all the numerators together. So 3x plus x plus 8 equals 4x plus 8 over 4. Now, hopefully you recognize that, hey, maybe I could do a GCF here. Because remember, this plus sign is gluing these two pieces together. I can't separate them. But what I could do is take a GCF of 4 out, and that would leave me with x plus 2 over 4. Now I can divide out that 4. And what does that do? Well, that leaves me with x plus 2. Now I ask myself, are there any restrictions? Well, since there's no x in the denominators, there's no restrictions. So x plus 2. So maybe make ourselves a note. We say no restrictions because there's no variables in the denominator. Okay? So there's no restrictions because there's no x in the denominators here, okay? That can help you as we go along. Let's look at number 3. X squared over x plus 2 minus 4 over x plus 2. Again, the denominators are going to match today, so x plus 2 looks great. Then the top is going to be x squared minus 4. Now I need to look and see how can I reduce this. Well, remember x squared minus 4, hopefully you recognize that as a difference of squares, which means I can do x plus 2 times x minus 2, all of it over that x plus 2. Now if I look at this, I can cancel out that x plus 2 factor, can't I? And what's left over is the x minus 2. Now let's think about restrictions. Go back to your original and look at what were there. X plus 2 was in the denominator. So what is it that would make this one undefined? Well, in my mind, if I set that equal to 0 and jump the 2 over, then x would be negative 2. So x cannot be a negative 2. That is my restriction on this guy. Let's look at number 4. T over t squared plus 2t minus 15 plus 5 over t squared plus 2t minus 15 equals what? Well, now don't let the t's mess you up, okay? Always put a little tail on the t so you don't think it's a plus sign. That's something you will see in pre-cal, so you got to get used to using other variables besides x here, okay? So okay, we know my numerator, I'm just going to bring everything together for the numerator, so t plus 5. The denominators match, so I'm just going to rewrite this. T squared plus 2t minus 15. Now, this is going to factor out. It's a trinomial, right? So what are we doing? We're going to multiply to negative 15, but we're going to add to a positive 2. What would do that? Well, a 5 and a negative 3 would work, right? So as I write this out as factors, so t plus 5 over t plus 5 times t minus 3. Now I look and my factors here reduce, the t plus 5 factors. Now everything's out of the top, but there has to be a placeholder of 1 there. And then t minus 3 is on the bottom. Now I need to go back and look at restrictions. What is it that t cannot equal? We'll go back to what this was when we broke it into factors right here. It cannot equal a negative 5 and it cannot equal a positive 3. Okay, notice the signs are switched here. That's what would make the denominator undefined. We don't want that. So make sure you check your restrictions in every factor. Let's try one more example. So we'll have x minus 3 over x minus 5 minus 7 minus x over x minus 5. Okay, so what you have to be careful of here is there's a minus sign here. And that's like a negative 1 being distributed across the back side of your equation. So let's be careful about this. Our denominator is the same, so we're just going to carry it over. But when I group the numerator, I need to change my sign. So this will be like a negative 1 times 7, so negative 7. Negative 1 times negative x means plus x. Now when I clean this up, I will have a 2x minus 10 over x minus 5. Now, is there a way I could reduce this? Okay, there's a GCF here. Do you see that? I could take a 2 out, and that leaves me with x minus 5 over x minus 5. Now, look at this. These reduce out, and I'm left with a 2. All right, well, maybe that's it. Now let's look back and see what kind of restrictions we may have. Well, the only restriction is with this denominator, x minus 5. So that would mean that x cannot equal a positive 5. All right, so I don't have to put that 2 over 1 because it's over 1. It doesn't change the value. So hopefully this all is making good sense to you, and let me know what questions you have when you get to class. All right, good luck. Thanks for listening.